Hello, today I'm going to talk about the aortic regurgitation. I will mainly talk about the detection of aortic regurgitation and the semi-quantitative analysis of the regurgitation. I will just mention the quantitative analysis, but this is way beyond the scope of focused echocardiography, and you should mainly get used to getting good images. Let's start with the etiologies of aortic regurgitation. So in acute AR, there are two main etiologies, which are aortic dissection and endocarditis. These two diagnoses will require the realization of a transesophageal echocardiography to really characterize the aorta and the disease of the aortic valve itself. In chronic regurgitation, it's most often due to aortic valve calcifications because the valve cannot close because of the calcifications, and it's also very often associated with aortic stenosis because if the valve cannot close, it cannot open neither. You can also have bicuspid aortic valve and congenital aortic diseases which can cause chronic aortic regurgitation. And finally, aortic root and annulus dilation, which will cause regurgitation because the cusps cannot coapt together to ensure a good closing of the valve. So how will you detect aortic regurgitation? You will have to use color flow Doppler. It's not possible to detect it in 2 dimensions. So you will look for a diastolic flow from the aortic valve into the left ventricle. And for that you will use 2 main views, which are the personal long axis view and the apical 5-chamber view. You can also use the personal short axis view, but quantification will not be possible. It will give you little insight on the diagnosis and the mechanism of aortic regurgitation. And you can use apical 3-chamber view, which is not one of the views of focused echo. Here is an example of an aortic regurgitation. On the left of the screen, you can see the personal long axis view with the aortic valve within the color sample, and you can see some flow, which is high velocity because you have aliasing, which is directed from the aorta to the left ventricle during diastole. So when the aortic valve is closing, you have that regurgitant flow, which is coming backwards into the left ventricle. Now if you look in the apical 5-chamber view, here is the aorta with the aortic valve, and you can see that during diastole you have a flow which is going from the aorta into the left ventricle. So using color Doppler, you will be able to do the diagnosis, positive diagnosis of aortic regurgitation. There are a few pitfalls for the semi-quantitative and positive diagnosis of aortic regurgitation. The first is make sure that you don't mix up with all the jets which can happen in diastole in the left ventricle. On the left of the screen is the jet of aortic regurgitation that we just seen, and on the right of the screen, in apical 4-chamber view, you can see a diastolic flow coming from the left atrium to the left ventricle, and this is the mitral inflow. So they're both in the left ventricle, both during diastole. So be careful not to confound the 2 of them. One way is to make sure that you screen through each valve, and the mitral valve is more posterior than the aortic valve. And also the aortic regurgitation will have higher velocity, so you will have an aliasing of the flow of aortic regurgitation, while the flow of mitral inflow will be more solid, only one color. Then you can look for interact signs, and in the case of chronic regurgitation, you will have left ventricular dilation because of the increased preload of the left ventricle. Then you will have volume overload, and the left ventricle will dilate. The function at the beginning will be normal, but with the evolution of severe aortic regurgitation, it may start to deteriorate. In acute regurgitation, you will have a hyperdynamic left ventricle, but with no dilation because that requires time to appear. Let's see now how you can assess the amount of regurgitation semi-quantitatively. So you will look for the size and extent of the regurgitant jet in the left ventricle. On the left of the screen, we can see the aortic valve within the colored Doppler sample and some regurgitant jet, which is a little bit wide but doesn't go very far into the left ventricle. We will check that finding in the apical 5-chamber view, and you can see that the regurgitant jet is only going very shortly into the left ventricle. Here is the aortic regurgitation, which is a very small jet and a very small regurgitation. So this would be a mild aortic regurgitation. In that example here, you see that the jet is a little bit wider. It's going a little bit further into the left ventricle in the parasenal axis view, but there's not that much difference. But if you move to the apical 4-chamber view, 5-chamber view, you can see that the amount of regurgitant jet is much more important than previously. Okay, it's going to mid-ventricle, so this would be a mild to moderate aortic regurgitation. Let's look at that last example. Here is a hyperdynamic and very tachycardic left ventricle, and you can see that you have as much flow going than backwards into the left ventricle. Let's look at the apical 5-chamber view, and you see that there is as much flow going backwards into the left ventricle than forward into the aorta. This is a severe aortic regurgitation. There are a few pitfalls in the semi-quantitative assessment of aortic regurgitation. The first is eccentric jets, because when the jet is not round and centered, depending on the angle at which you're looking, you may under or overestimate the amount of regurgitation. So you will have to screen through the valve to really assess the amount of regurgitation. Also, if you change the gain, the color gain, you may increase or decrease the aspect of the regurgitation, and you can also do that by changing the color scale, transducer frequency, and wall filters, which will either increase or decrease the regurgitant jet that you will see from the echocardiographic images. So always make sure that you're back to the baseline settings of your echocardiography machine, and always be very critical against your findings. Using semi-quantitative estimation, you will be able to say if there is nothing, a little bit, or a lot of regurgitation. But you won't be able to look for mild compared to mild to moderate, and these subtle classifications will not be possible. You will, for that, require to do some quantification, but which is out of the scope of focused echocardiography, requires much more time and training. But something which is important to do is look for associated diseases. I told you earlier that the most frequent cause of aortic regurgitation was aortic calcifications of the valve, so you will always have to look for associated aortic stenosis. If you look at the aortic valve here, you see lots of calcifications, and you can see that the opening of the valve is decreased. When you look at the color, you can see that you have aortic regurgitation, and then you can confirm it in the apical 5-chamber view. So when you look at the valve, always look in the 2D first to try to see how the valve is opening and closing, and then put the color to see if there is any regurgitation or any acceleration through the valve. The function of the aortic valve depends not only on the left ventricle, on the valve itself, but also on the aorta. If you have a dilation of the aorta, you may have a stretching of the annulus, and then the cusps will not be able to coapt together. That will create aortic regurgitation. So on the left part of the screen here, we see a significant amount of aortic regurgitation, but we will need more views to quantify it. But if you look on the 2D images, you will see that the aorta is very dilated, and that you have a structure floating in the aorta, which corresponds to the aortic dissection. Okay, the dissection thread coming through the aortic cusps during diastole prevents the effective closing of the aortic valve. When you assess one of the valves, here you would assess the aortic valve, you also need to take a look at the other valves, i.e. the mitral valve, tricuspid and pulmonic valve. Most important is the mitral valve. So you will start with a 2D by looking at how the valves are opening and closing. And we see that they're opening and closing, they don't seem too restrictive. Then you will put the color and you confirm that there is an aortic regurgitation which is anterior here, but you will also find a mitral regurgitation which is posterior. It seems to be a small regurgitation, mild. Then if you go to the apical 4-chamber view, focus on the mitral valve and confirm the presence of a mild mitral regurgitation, and then go to the apical 5-chamber view where you will look at the aortic valve and see that there is a mild aortic regurgitation as well. And always remember, always look at the left ventricular function, right ventricular function, other valves, and look for pericardial effusions and estimation of volume status. Now I will mention very quickly how to quantify aortic regurgitation. This is out of scope of focused echo, and you should not do that unless you have very extensive training and some feedback from more experienced operators. So this is just for information and not to do in focused echocardiography. Ways to quantify aortic regurgitation are the vena contracta, the aortic velocity in the aortic arch, the conversion flow, which is the PISA, and the pressure half time. The vena contracta, it corresponds to the smallest area of regurgitation across the valve. So it's basically the size of the hole in the valve. So we will look at it from the personal long axis view, zoom on the aortic valve. You will use the colored Doppler and measure the narrowest diameter of the flow aliasing. And depending on the width of the vena contracta, you will be able to classify it between mild, moderate, or severe. You can also look at the telediastolic velocity at the aortic isthmus, and you will put your pulse Doppler sample just at the isthmus at the proximal part of the descending aorta. And you will see first a negative flow which is going away from the transducer, and that corresponds to the normal ejection through the aorta. And then during diastole, you will see some flow reversal, which will be positive and going backwards into the aorta and towards the heart. So the higher the velocity and the longer time of aortic flow reversal, the most important the regurgitation is. Another thing that we can do is use the continuous Doppler. The first thing is that you will look at the grayscale and compare the forward flow to the backwards flow. The more intense the signal of the backwards flow will be, the most regurgitation you will have. But you will also look at the shape of the regurgitation. And here is the positive flow, which corresponds to the aortic regurgitation. You have the baseline, and if you have a small regurgitation, you will see the forward flow, which is negative, and then you will see the backwards flow, which will look like a rectangle, because we just have a little bit of regurgitant flow, which will not impact on the telediastolic pressure of the left ventricle. If you have a lot of regurgitation, you'll still have the forward flow, but then you will have a rapid equalization of pressure between the left ventricle and the aorta, and the slope will be much steeper. So then you will look at the speed of the deceleration and the time it takes for the pressure to decrease by half. And this is called the pressure half time. The steeper it will be, and the most regurgitation you will have. Here is a summary of the criteria for quantification of aortic regurgitation. Once again, this is way beyond the scope of focused echocardiography. This is just for information. Thank you very much for your attention.